We'll go through, talk about some grading stuff, how to do an appointment if you want, and we'll go through, take a look at some slides. So um, live session, pardon me, that's where we're at. Then grading stuff, just so you all know, in Google Classroom. So if I go here and I go to Google Classroom, this is how I find the stuff that I need to turn in. As a teacher, when I hit view all, that shows me the stuff that's been turned in. And so the numbers over here are the things that have been turned in. And then when I return them back, it shows, hey, these things have been graded, these things haven't. So that's how I know what I'm going to be scoring and what I need to take a look at. Are you guys able to see that Google Classroom screen? Yep, good. Thank you for the head nod. I appreciate it. So please don't just always turn something in just because it's a certain shade. Take a look and see if it's work that needs to be done for. So for you guys, if you go to classwork and then up here, there's like view my work or whatever. That little spot shows you what work you need to do in here. Clicky. All right. And I return it to you guys after I've done whatever I need to do to enter it into the Skyward gradebook as well. If you feel like you need to schedule an appointment with me, you can go to classwork and then in here under the resources, I thought it was under the resources. Maybe it isn't. Uh-oh, where did I put it? There it is. I'm sorry, it's under today. There's physics appointment with Lulai. So if you want just to say, hey, there's an issue, I've got a question, things aren't working, you can just click on that physics appointment with Lulai. Calendar shows up and you choose a spot. I think I spoke about this last week. I don't remember for sure. So I wanted just to make sure you were aware. And then when that pops up, any of these spots that show up as Lulai Phys appointment or something like that, you can click on one of those, save it, and you're set. Then, oh, that's the other thing. The Google Calendar. A few folks have mentioned that in this class and in others, I have a class with some juniors and seniors. A few folks have mentioned that they're not seeing class show up on their calendar. Others are seeing it show up. So I just want to make sure you know how to do a quick double check. If you click on Google Classroom there, and then you click on the calendar, up should pop a bunch of stuff. And if it's not visible, there we go. If the class that you're looking for isn't visible, then usually it's available over on this left-hand side over here. There's this My Calendars and Other Calendars spot. So if you check on one of those, you can usually end up finding it over there, and you just make sure to check on it to have it show up, and then it should show up there. And then in the calendar for the class appointments, I have the links for these Google Meets and stuff set up as well. All right, I think that's all of the hullabaloo there. Oh, I put the link to your, was it first week of class? I asked you guys some questions. What should I know about you? What's important to you? Those sorts of things. And some of you asked me a few questions. I put a video link to that right there. So 6 minutes in, that's not too bad. Keeping time moving. We're going to review some slides and try to get some stuff going that will hopefully set us up for the assignment that we're working on today. So, clicky. We'll do there. There we go. All right. So we're going to review position versus time graphs with a couple of questions. And then we'll do a practice problem that sets us up for the homework assignment today. Excuse me. So first question, I couldn't find an image of yesterday's game that quickly. Nobody makes GIFs in 6 hours, it seems. Um, but there's V. Delvin Cook. Oh, beautiful site. So position versus time graph. Let's see. I'm going to try asking a question for you guys again using this thing. There. Come on. This is slow. So that multiple choice spot there. Um, that's the question for you. How do I do that? No questions. Ask a question. There it is. So in Google Classroom, I'm going to, pardon me, in our Google Meet, too many Googles. In our Google Meet, I'm going to try to ask this question. Um, so, question posted to Google Classroom. If you open the right side, there's a question posted, and I hope to see uh, answers populate. I don't remember exactly how that throws. Um, so if we use the little GIF as our example of the motion, and then our graph is where we're at. So with the ball there, moving left to right, we have this arrow kind of setting things up. Our graph looks like this. We have a positive slope starting away from zero. They didn't start at the end zone. They started a little farther away from the end zone, from the opposing end zone. All right. So, has anybody had a chance to answer that question in the Google Meet? That multiple choice question is in Google Meet. Clickety clack and answer. I've got one answer. Come on, y'all. You can do it. I believe in you. Getting a few now. Are you guys able to see everybody's answers or no? No. One person nodded and one person shook their head. You can see other people's answers? Okay. Um, well, uh, B and E are definitely, well, actually, E, while it includes some true statements, does not accurately relate to the slope of the graph. Um, B does. B, the slope tells us how fast the object moves. That's definitely true. There's one more in there that is accurate for something that the slope tells us. What's the other one? The slope does tell us how fast. Like if we calculate it, the number tells us how fast. There's one more thing the slope tells us. D. Not seeing it? Yeah, A. Yeah, it also tells us the direction of the object. Nice job. So if we have a positive slope, we're up and to the right. If we have a positive slope up and to the right, then we're moving in the positive direction. And for this GIF, positive, put that arrow in there pointing to the right with a positive there. So for this GIF, to the right is positive. If we have a positive slope, rise over run is positive, then we're moving in the positive direction. So the slope tells us two things: how fast and which way. Um, and instead of saying how fast and which way, in physics, we put those two things together and we say velocity. So the velocity is both how fast and which way. So if we have the slope of this line, the number tells us how fast, the sign tells us to the right or left or up or down or any of those sorts of things. Hey, go team. All right. Another question for you. Um, y-intercept for that graph. So y-intercept tells us what? I just threw that one on there. That's also a question there in Google Meet. So we have that graph, position time graph. Okay. And if we're all seeing everybody's answers, then when somebody answers, we all kind of can roll in on it. Yeah, we get to that. I need to find a way to make that a little bit less awkward there. Sorry about that, folks. And you, whoops, and yeah, you guys are right. The y-intercept tells us the position of the object at 0 seconds. So this is telling us that the object did not start at 0 meters. This is 0 meters. This is a positive direction, negative direction. So in this case, we know the object did not start at 0 meters. It started at something positive, like Dalvin Cook in the previous slide. Didn't start at the 0 yard mark or the end zone of one side and have to go all the way over. Started midfield range. Didn't start on an end zone, started kind of halfway through and then went to glory. Okay, so from graph to equation, we've done this a few times, but I want to make sure we're getting there. So here we have another straight line on a position time graph. And every straight line everywhere, y equals mx plus b. Okay, so then some practice for this stuff. Let's see, we'll get that over here. So I just put some numbers in on that graph, and we'll go through, take a look at how we would calculate the velocity from this graph. So if we're going to calculate the velocity, we're still looking at this general layout, but now we have this beautiful, delightful graph with numbers present. Our first step is to go through and figure out what data we can get from the graph. Now that means things that it flat out tells us, and that means other things that we also just happen to know. So if we go through and use those two things, what we know and what it tells us, that helps us out. So step one, data. And if we look at the graph, there are some things that we can figure out or find. Final position, starting position, final time, starting time, and then there's a spot for velocity there. We don't know the velocity, but it's a thing that we're interested in, so we can put that down as like a starting point for what sort of stuff we've got. I'll give you guys a couple of seconds. See if you can fill in what those values are just from reading the graph. I'll give you guys a couple of seconds to put that down, and then we'll see where we go from there. Okay, you guys ready to take a look? Getting a couple of head nods and thumbs up and stuff like that. So first things first, one of the things that a lot of people skip when they're starting problems, when they're starting physics, I should say, and myself included back in the day, and just about everybody, one of the things that we tend to skip is like this step. Sometimes this feels like an unnecessary step, but in the world of psychology and cognitive sciences, where they talk about and try to figure out how we best solve problems and how we do things, this is doing this does what they call, it lightens the cognitive load. So in the next steps of problem solving, we won't have quite so much crap to keep sense of in our head. if we do these steps initially, that makes each subsequent step a little bit smoother, a little bit easier. So, uh, bloop. Oh, we apparently went two there. Or I forgot to separate it out. So step one then for DF, I said 15 meters, right? Because we have our first position here, like early in time. And then our second position is up here later in time. So I said DF is 15 meters. DO is 5. TF, when it ends, is 5 seconds. And TO, when it starts, is 0. And I don't know the velocity, so I just threw that question mark in there, V equals question mark. And then step two is coming up with a plan. And that's really just, hey, what equation are you going to use? There you go. And then now that I think about what I put here, I made a mistake for what I'm going to do next. So I'm just going to leave it on this screen. So step two is, what is your plan? Lay out the equations you're going to use, what sort of stuff are you going to throw in, and that with no numbers, right? I want us to do this just symbols and letters. Otherwise, at this state, we stop thinking physics and we don't think about positions and times and velocities. And I want us to be thinking about positions and times and velocities. So this is equation with no numbers. And then the next step, step three, is execute the plan or plug in numbers and units of measure and those sorts of things. So step three, you can start right now. Step three, plug and chug, throw your numbers in. If I hit the next screen, I think I put the numbers in there already. I want to give you a chance to do that first. I wonder if I can throw that in here real quick. Maybe not. Okay, okay. So, and here I abbreviated do it. I just ran out of real estate on the screen. But the plugging the numbers in with units and measure, we should be looking at something like that. Yeah. And then the last state is just, the last step is just show your answers. And we want to include units of measure every single time. If we're face to face, I always say then every time there's a number, there should be a unit of measure. Over here, every number has a unit of measure, 15 meters, meters, seconds, seconds. Every number has a unit of measure there. Over here, every number has a unit of measure there, trying to make sure that we keep some sense of meaning about what these things are. And then when I state my answer, 2, and then, so I do the math with the numbers. 15 minus 5 is 10. 10 divided by 5 is 2. 2. And then I follow the same math with the units of measure. I have meters on top, seconds on bottom. Those don't divide out to 1 or cancel or anything like that. So we just end up keeping both meters on top, seconds on bottom. And that's velocity for that line, the velocity for the object that made that line. How are we doing there, folks? Yeah? All right. So the assignment that you guys have today is basically going through and doing calculation problems that are really very similar to this. Um, if you haven't taken a look yet, um, where did it go? Oh, there it is, calc practice. So if you open that bugger up, there's a spot for you to put stuff in here. Um, you can either type your answers into the sheet, or if you'd rather pencil paper, I would much personally, my preference when I'm solving stuff and trying to figure stuff out is to write things out pencil paper. So um, if you would rather pencil paper, I totally understand, and you surely can. Um, I did another example problem here. But when you're going through and working on these, you can either in this spot in here, you can either type stuff out, or if you'd rather, you can write things out on pencil and paper, take a picture, and try to insert the image into that spot. That's perfectly fine as well. Does that make sense? Okay, head nods, thumbs up. Awesome. That's all I got for you. I'm trying to keep things around a half hour. If we're going to meet twice a week, then if I give you about a half hour of stuff, then you have time to work and we can hopefully get everything done in the hour or so that we're shooting for. I'll stick around for a few minutes. So if you have questions, you can ask. Otherwise, I'm done. So if you start hanging up, I'll be okay. Have a good day. Skol Vikings. Thank you guys. Have a good one. See y'all.